Hey there, welcome back for another video lesson with Mrs. McGuire. Um, we are going to learn some simple and easy truths about interior and exterior angles about regular polygons. And we've talked about this before, but regular polygons, and we have 4 examples. We're starting with a regular triangle, which means that all the sides are congruent and all the angles are congruent. And you know that as an equilateral. So the word regular polygon means all sides are congruent and all angles are congruent. So we've got a triangle and a square, which you're super familiar with. So we're going to start with these two. And then we're going to build on those ideas with a pentagon, 5-sided, right? And this is a very nice looking pentagon because all the angles are congruent and all the sides are the same length. And then we have a decagon, 10 sides, like deca means 10. So this is a 10-sided polygon. And again, all the sides are congruent and all the angles are congruent. So we're going to take a look at these figures and we're going to fill in this chart below us. And our goal is to find out what's true about all regular polygons and how the interior and exterior angles relate to each other. So we're going to start with our triangle. You guys know all of these sides are congruent. We can put little tick marks on them. And you should know how big each angle is. 60 degrees, right? And these are our 3 interior angles. So when you look at the sum of the inside, you know that every triangle has a sum of 180. So let's go ahead and fill this out below on our table. So we've got number of sides is 3 for our triangle. Number of triangles inside. And we're going to be taking a look at this. This helps us figure out our interior angle sum. But we have 1 triangle, right? 1 triangle. And so that's 180 degrees. Now we're going to take a look at each exterior angle. Now we have spoken about this before, so this is not new to you, but you guys know that if we take a side and just extend it out, we get an exterior angle out here. And you guys already know that the exterior angle and the interior angle have a special relationship. They're supplementary to each other. So the interior is 60, the exterior is 120. And you're going to find that's true as you draw all the exteriors out here. They're all 120 degrees. All right, so there we go. Each interior angle is 60 degrees. And each exterior angle is 120 degrees. And then the exterior angle sum. Well, if we add the exterior angles up, 120, 120, 120, we get 360 degrees. Pretty simple so far. Let's go ahead and look at our square. So again, yes, it's a quadrilateral, but we're focused on regular polygons. So our regular quadrilateral has to be a square because that's where we have all 4 angles. And you guys know these are 90 degrees. And all 4 sides are congruent to each other. So there's our regular quadrilateral, our square. So let's go ahead and start filling in our chart below. We've got number of sides is 4. And then the number of triangles. So the idea for the number of triangles is it's helping us to get our interior angle sum. And so when we look at the triangles, we can just use 1 diagonal. And here's 1 triangle, and here's 2 triangles. Now some of you are thinking, well, Mrs. McGuire, stick with me, and don't do this on your picture. I'm going to do this with a pencil. What if I drew the other diagonal? And now I've got 4 triangles, right? Well, here's what I'm trying to get you to understand is we're focusing on the angles. When I add up these angles, when you bring in these triangles, you've created a bunch of angles in the middle that are not actually part of the interior angle sum. So I'm going to take that off of there, and we're going to focus on our two triangles. And this should make sense to you because we've studied quadrilaterals, and you guys should know and understand that there's two triangles in here, and 2 times 180 is 360. That's the total degree measure. Right now, each interior angle is 90 degrees. So how big is it each exterior angle? Well, we don't have to draw all of them, but if you create an exterior angle, that's going to be 90 degrees also. Let's just do 2 of them. Here's one up here, 90 degrees. So each exterior angle is also 90 degrees. And then our exterior angle sum. Well, we have 90 times 4, which is 360 degrees again. All right, on to our pentagon, something a little bit unknown here, our 5-sided friend. And so we're going to look at the same thing. So pentagons, let me pull this up just a little bit. Pentagons have 5 sides. And how many triangles are inside of them? So what you're going to do is you're going to pick one vertex, and you're going to create diagonals. So we can pick this vertex over here, and we can make a diagonal this way and a diagonal this way. So you have one triangle for 180, a second triangle for 180, and a third triangle for 180 degrees. All right, so that's 3 triangles. And if we do 3 times 180, we get 540 degree total inside of every pentagon. Now here's the thing, every pentagon has 540 degrees inside of it. We're looking at regular pentagons. So when you look at a regular pentagon, we can take that 540 and divide it by 5. And what do we get? We get 108 for each angle. So every angle on the inside is 108 degrees on a regular, has to be a regular pentagon. So for 108 on the inside, we can create our exterior angle, and we know this has to be 72 degrees on the outside. Like this one up here would be 72 degrees on our exterior angle. And then if you do 72 times 5, what do you get? Yeah, you get 360 degrees again. See a little pattern forming there? Ooh. Alrighty, our last one is our decagon. And yes, that is a beautiful computer-generated 10-sided regular decagon. Don't try that by yourself. It doesn't work out too well. So we've got 10 sides. How many triangles are we going to see? I'm going to grab my ruler and make this nice and neat for you. So let's go ahead, and from one vertex, we're going to create all the triangles. Alrighty, so how many triangles did we create in our decagon? Come on, little thing. You should have 1, 2, 3, 4, 5, 6, 7, 8. So 8 triangles inside of there, and 8 times 180 is 1,440 degrees. So each of them is going to be 144 degrees. Each angle is going to be 144, right? So this is 144, this is 144. And you notice as we get larger, as we get a larger amount of sides, these angles on the inside, these interior angles are getting really, really big. Now they will not go past 180, right? Or they won't be the polygons that we're studying anymore. We've got 144, but they'll get more circular They won't become a circle, but they'll get more circular. Okay, so 144 minus 180 is going to give us 36 degrees for each exterior angle. So if we draw these out, and you can see these are much smaller, right? These are 36 degrees out here on the outside. I got another one over. Oops, I didn't do that. So 36 degrees, right? They're coming off everywhere. This is 36 degrees. But on the outside, since there's 10 interiors, there's going to be 10 exteriors. So 36 times 10, don't say corona, is 360 degrees. All right, so now what we're going to do is take what we've learned from these 4 different polygons, these 4 regular polygons, and we're going to talk about what would it look like if we had just n number of sides, right? If we had an n-gon, just n number of sides, we don't know how many triangles would that be. So look at the pattern that you see here. 3 sides has 1 triangle, 4 sides, 2 triangles, 5 sides, 3 triangles, and 10 sides, 8 triangles. So it looks like we take the number of sides and subtract 2. And that's how many triangles we're going to do. Now, to find the interior angle sum, we did the number of triangles times 180. So that's what we're going to put here, n minus 2 times 180 degrees. All right. To get each interior angle, we're going to take this sum and divide it by the number of sides or the number of angles because they're both the same. So we're going to do n minus 2 times 180 degrees, all divided by n. Now, I have to specify that this is for regular polygons, right? If it's not a regular polygon, this doesn't work. This will work, but not the each interior. All right, then so each exterior is just a supplementary relationship. So here's an easy way to do each exterior. Did you notice that the exterior angle sum is the same for all of them? This is true for every single regular polygon or every polygon on the planet. All the exterior angles, and you think about you're going to go around the exterior, are always going to add up to 360 degrees. So if we have a regular polygon, we can find each exterior angle just by dividing by the number of sides. We can do 360 degrees divided by n. Now here's the cool thing, and you want to make sure you understand this, is that these 2 categories right here, the interior angle and the exterior angle, they are supplementary. So that's going to help you figure out some of your problems. All right, let's go to the second page. Now I have another table for you on the second page. We are not going to go through and fill out this entire table. But the reason why I have back here is that if you want to try some of these formulas and work this out, you can. What I really need you to understand are the names of the polygons. So a hexagon has 6 sides, a heptagon, 7 sides, an octagon, that should be super familiar, 8 sides, a nonagon is 9 sides, and this is a dodecagon. This is 12 sides. We don't have a special name for an 11-sided polygon, and then anything above 12 is just its number hyphen gon. So if you had a 102-sided figure, it would be 102 gon, all right? But you do need to know the names of your polygons because that will show up on your quiz. And so let's just review our formulas that we're going to use in our problems today. And here, these first 2, the interior angle sum and the exterior angle sum, these work for all polygons, all right? But these 2, the regular polygons only when you get down and you're looking at each interior angle and each exterior angle because they're all the same because they're regular. All right, so for our interior angle sum, it's going to be n minus 2 times 180 degrees. For our exterior angle sum, that one's super easy. That's going to be 360 degrees. All right. Now, to find each interior angle, you're going to take the sum and divide it by the number of sides. And so we're going to take this, n minus 2 times 180 degrees, and divide it by the number of sides. And then to find each exterior angle measure, you're going to take the total exterior and divide it by n, the number of sides. So they're very relatable. They're very easy. Yes, you need to memorize these. You'll need them on your SAT, and they do not give it to you, so you need to memorize these. All right, so I have 5 problems for us to work on together. We're almost there, my friends. So number 1, it says the sum of the measures of the interior angles of a convex polygon is 2,700 degrees. Classify the polygon by the number of sides. Classify means tell us the name of the polygon, right? When you name the polygons by their number of sides. So they are giving us the sum of the interior angles. So they are giving us the n minus 2 times 180 degrees equals 2,700. You go ahead and solve that, please. All right, what'd you get? Did you get a 17 gone? How many of you put 13? Here we go. The easiest way to solve this is let's divide it by 180 degrees on both sides. I gave you nice numbers, didn't I? Because the zeros cancel, and 270 divided by 9 is 30, and 18 divided by 9 is 2. So this comes down to 15. So you've got n minus 2 equals 15, and then add the 2. I bet some of you subtracted. So n equals 17. So we have a 17 gone. That is its name, with 2,700 degrees inside. Alrighty. Number 2, find the measure of each interior angle of a regular heptagon. I'm going to let you try this on your own because it's just a formula. So go grab the formula for each interior angle of a heptagon. Okay, so you might have rounded this up to 128.6, or maybe you did 129. Either way, those are acceptable answers because I didn't tell you where to round to. But the first thing you have to understand is your formula. Each interior angle. So we're going to do n minus 2 times 180 divided by n. And a heptagon is n equals 7. Right? It's a 7-sided figure. So we're going to plug this in. We're going to do 7 minus 2 times 180 degrees divided by 7. You can grab your calculator and do that, and you're going to come out to like 128.5. I don't remember, but it does round up to 128.6 degrees. Now, I'm going to show you a second way to do this problem because that's the straightforward method. There's another way that you could look at this. Box that in. So the other way to do this problem is let's go from the exterior, right? You know that on the exterior, there's always 360 degrees. And you can divide that by 7 because it's a heptagon. So you're going to get 51.4 degrees. Now here's the thing. This is the exterior. And remember, the exterior and the interior have this supplementary relationship. So then we can just do 180 degrees minus the 51.4. And that's where we get the 128.6 degrees. So that's another way to do the same exact problem. I don't know. I like this better. I don't know why. But both of them work, so either one is fine. All right, number 3. Number 3, find the measure of each exterior angle of a regular 18agon. You can do this one. All right, did you get 20 degrees? I hope so. So exterior angle measures, lock this in, 360 degrees around every single polygon, and it's an 18-agon. So we're going to divide that by 18, and you know 18 times 2 is 36, right? So each exterior angle is 20 degrees. All right, number 4. My number 4 had a typo Mrs. McGuire made, but yours should be fine. It says each interior angle of a regular polygon is 120 degrees. What is the name of the polygon? What is the name of the polygon? So this is each interior angle. So you could do this way. You could do n minus 2 times 180 divided by n equals 120 degrees. That's the first way, and you can solve for n and get your answer, or you can go backwards, right? What's 360 divided by 120? Oh wait, we don't want to do that, sorry. Back it up, Mrs. McGuire. This is our interior angle, right? So if I have 120 on the interior, how much is on the exterior? 60 degrees, right? And I've got 360 divided by 60 degrees, because they're all the same, it's regular, and that is going to give me 6. N equals 6, which is a hexagon. Yay. All right, last one, number 5. Now, if you are looking at the Ed puzzle, you probably can't see these little numbers, so you need to go look at the actual document and make sure you can read those numbers well. Actually, I'll just tell you real quick. This is a 59 degrees, 50 degrees, 35 degrees, 2y, 61 degrees, and a y. Go ahead and find the value of y. All right, this did not work out pretty. It's a decimal, and that's fine. Hopefully you've gotten 51.67, 51.7, or maybe you rounded up to 52. I'll take them all. That's fine. So you're going to add these up. It doesn't matter where you start, but going around the outside, we're going to add them up and set them equal to 360. So we have 59 degrees plus 50 degrees plus 35 degrees plus 2y plus 61 degrees plus y equals 360. Bam, there it is. All right, combine your like terms, and you're going to have 3y plus 205 degrees equals 360 degrees. Subtract your 205, you get 155 degrees. This is a 3, sorry. And so dividing by 3, y is going to equal 51.6, repeating, and you can round that however you like. All right, hope you learned a lot. There's a worksheet waiting for you for homework. Bye-bye.